Hello everyone. In today's lecture we are going to focus on the factors affecting on the ionic radii. In last lecture we have discussed about the factors affecting on atomic size. Okay. Now first of all we will discuss in the manner first definition, then factors and then it trends. Okay. Now first we will discuss about its definition. Okay. Ionic radii is defined as the distance between the nucleus and the point at which the nucleus exerts its influence on electron cloud. Again, I am repeating the definition of ionic radii. Ionic radii is defined as the distance between the nucleus and the point at which the nucleus exerts its influence on an electron cloud. Okay. Now, there are some important lines relating to this ionic radii. Which are these? Before going to discuss this, we have to focus on this ionic radii, which is divided into two types. First is positively charged cations and negatively charged anions. Okay. Ionic radii are formed by positively charged cations and negatively charged anions. Okay. Now, here we are going to focus on the radius of a cation and that of anion. Okay. See here. In your exam, there may be a question is that is the radius of a cation is smaller than that of radius of a anion. Now, in this statement, we are going to explain this by taking the example of a sodium of atomic number Z is equal to 11, okay, of electronic configuration as 1s2, 2s2, 2p6 and 3s1, okay. That is total number of electrons equal to 11. 11, that is last electron will enter in last S shell. Okay. Now, here the formation of cation will take place as cation formation due to loss of electron. Due to loss of one electron. Okay. That is sodium from its metallic state or zero state gives rise to Na plus 1 electron. Okay. Now in this sodium, how many numbers of protons and electrons? That is 11 protons plus 11 electrons. Now the loss of 1 electron gives rise to here 11 protons plus 10 electrons. Okay. What about the ionic radii of this? That is of sodium in metallic state, that is equal to 181. Okay. And due to that value is going to, that is 102 picometer. Okay. Now here decrease in the radius of a ionic cation. Why it happens? Because as the conversion of sodium in metallic state to its cation, that is cations are formed by the loss of one electron. Okay. As here due to loss of one electron, here number of electrons are lost, therefore nuclear charge is increases on less number of electrons. Okay. So therefore effective nuclear charge as a result is increases due to less number of electrons. Hence the attraction between the electrons and nucleus, hence the attraction between electrons and nucleus is increases, and that is why this is the reason due to which the radius of a cation is smaller than that of anion. Okay, I am again reminding to you, that is cation is formed by the loss of electron, and loss of electron is nothing but the oxidation. Okay, already you know the definition of a oxidation. For example, in sodium in metallic state gives rise to sodium ion with loss of one electron. As the electron is lost, total number of protons and electrons in metallic state 11 protons and 11 electrons, while in formation of a cations 11 protons and 10 electrons. As far as ionic radii values is considered, it is to be in metallic state 181 picometer, while in ionic form, that is in cationic form, 102 picometer. Why this happens? Because due to loss of electrons, the nuclear charge per electron is increases on less number of electrons. As a result, effective nuclear charge on the electrons is increases, and thus attraction between the electrons and positively charge is increases. That's why the radius of a cation is smaller than that of a anion one. Now next we will consider the case in case of a anion. The statement is opposite to that, that is radius of a anion is larger than the radius of a cation. Okay, for that purpose we will take the example. That's why like this. For that purpose we will take the examples here. That is Cl when accepts one electron, it is negatively charged. Okay, in aqueous state. Okay, here Cl having 17 protons plus 17 electrons. Here 17 protons, okay, plus 18 electrons. Okay, now as far as its value is considered, and that value is corresponds to, here I am going to give the value as, that is 99 picometer for Cl0 and 181 picometer for the negatively charged Cl minus ions. Now here number of shells of as far as electronic configuration is considered here, that is 287, and here 288. While in case of sodium, what is the electronic configuration? That is 2. Okay, 8, 1, that corresponds to sodium ion, corresponds to 2 and 8. Here decrease in the electron or the loss of electron. But in this case here, which reaction takes place? That is the reduction reaction. Reduction means gain of electrons. Okay, therefore there is increase in nuclear charge due to the addition of a electron, and thereby the attraction between the positively charged nucleus and the electrons is going on decreases. Okay, therefore the values for this radius of an anion is from 99 picometer to here 181 picometer. The reason behind this is that here, as the electron is added, the effective nuclear charge is going to be decreased. Why? Because due to the addition of an electron, there is increase in quantity of the electrons and less nuclear charge is acted upon it. Therefore, nuclear charge is decreases. Okay, as nuclear charge decreases, the attraction between the positively charged nucleus and the large number of electrons which are present in the outermost shell, this is decreases, and that's why the reason is that is the radius of an anion is larger than the radius of a cation. Okay, now we will discuss the factors affecting on the ionic radii. There are some factors here. Hello everyone. In today's lecture, we are going to focus on the factors affecting on the ionic radii. In last lecture, we have discussed about the factors affecting on atomic size. Okay. Now, first of all, we will discuss in the manner first definition, then factors, and then trends. Okay. Now, first we will discuss about its definition. Okay. Ionic radii is defined as the distance between the nucleus and the point at which the nucleus exerts its influence on electron cloud. Again, I am repeating the definition of ionic radii. Ionic radii is defined as the distance between the nucleus and the point at which the nucleus exerts its influence on an electron cloud. Okay. Now, there are some important lines relating to this ionic radii. Which are these? Before going to discuss this, we have to focus on this ionic radii, which is divided into two types. First is positively charged cations and negatively charged anions. Okay. Ionic radii are formed by positively charged cations and negatively charged anions. Okay. Now we will discuss about the trends in ionic radii. Okay. In trends, there are 2 points. First one is along a group group, and second one is along a period. Okay. As far as along a group is considered, ionic radii goes on increasing from top to bottom. From top to bottom, the values are listed in this, after this, and along a period, we can't consider the values along a period, because in a period there is a presence of some metals along with a non-metals. So we can't recognize the values of ionic radii, either increases or decreases. But we have to consider here the isoelectronic species of a ionic radii. We may assuredly say that is ionic radii of isoelectronic species, that is isoelectronic species of ionic radii are decrease in along a period. Okay. Now what is meant by isoelectronic species? The species which possess same number of atomic number, but different in the magnitude of a nuclear charge. That species is called as isoelectronic species. Now we will discuss along a group what are the values of ionic radii. See here what are the values. Okay, I am going to give you the values of a ionic radii, that is from Li plus, beryllium plus, boron plus, beryllium 2 plus, boron 3 plus, carbon 4 plus, okay, then nitrogen 5 plus, then oxygen 6 plus, and fluorine 7 plus. Okay, the values are, that is from 58, 27, 20, 15, 11, 9 and 7. Okay. While go from along a group Na plus, K plus and rubidium plus, the values are for sodium 102, for K 138 and for rubidium 149. Okay. Now here along a group, okay, that is from lithium, sodium plus, potassium plus and rubidium plus, here the values are going on increases, that is from top to bottom, that is these values are expressed in picometer. Okay, that is when we are going from, that is from lithium to fluorine with its different oxidation state, lithium plus, beryllium 2 plus, boron 3 plus, carbon 4 plus, nickel 5 plus, oxygen 6 plus and fluorine 7 plus. The values are somewhat decreasing in nature along a period. These values are for beryllium 27 picometer, for boron 20, carbon 15 picometer, and nitrogen here 11 picometer, oxygen 9 and fluorine of 7 picometer. That is, we can easily say that the ionic radii values are increasing from top to bottom, and from along a period, in case of isoelectronic species, these values are decreasing from along a period. Okay, thus we have discussed here ionic radii, the radius of a cation, radius of an anion and the trends in the periodic table. If you like my video, please share and subscribe the video. Okay, thank you.